Hi, welcome to 11.6 notes. I will not be here tomorrow. I am sick, running about 101 degree temp. Headed to the doctor as soon as this video is over. Make sure that you do your stuff, do your work. Should be about 18, 19 minutes worth of a video. Okay, maybe about 20. Here we go. First off, example number one, I've got x plus 6 times x minus 6. So x plus 6 times x minus 6. Well, I know that this is two binomials, right? And with two binomials, I want to FOIL them to produce, get a product, right? I want to multiply the two binomials together. That's what it's asking us to do. So we do that by FOIL. I'm going to take the first terms and get x times x, or x squared. Take the, and write that a little bit lower, outside terms, and that's x minus 6, or negative 6x. 6 times x, or positive 6x. And then my last, 6 times negative 6, or negative 36. When I go to combine like terms, I'm going to notice that this negative 6 and positive 6, they're going to cancel each other out, leaving me just x squared minus 36. Well, when I notice this, I notice I'm down to two terms and not my typical three terms, not my typical quadratic trinomial, right? I'm down to two terms. Well, this thing right here has a special name. It's called a difference of squares. It's called a difference of squares. And it has a very distinct pattern. What pattern do you notice? Well, one, I know it's subtraction between two perfect squares. And we know that x squared is a perfect square of x times x. We see that x times x gives us x squared. That's a perfect square. Because if I take the square root of x squared, I just get x. Well, I know 36 is a perfect square of 6 times 6. So this is called a difference of squares, and it is subtraction between them. Subtraction sign between two perfect squares. With this pattern, we will always have one of each sign when we factor. Meaning, whenever I have a difference of perfect squares, if I had x squared minus 25, I'm going to have one of each sign. And that is, I'm going to look at it and it's going to be x plus, x minus, and then I'm just going to take the square root of whatever that value is. If as long as it's a perfect square, it comes out to be clean. In this case, it'd be 25. It'd be x plus 5 and x minus 5. Okay? So those are difference of squares. The next one, x minus 4 squared. What that is saying is x minus 4 times, remember, to square means to have the same term, number or term, multiplied by itself. So this is x minus 4 times x minus 4. And if I FOIL this, first, outside, inside, last, I get x squared minus 4x plus 16. And I get x squared minus 8x plus 16 when I combine like terms. Well, this also has a very particular name. This is called, this product right here, the product is called a perfect square trinomial. And it's a particular name for it, okay? And it tells you a lot. To recognize that this is a perfect square trinomial allows you to factor it much easier, okay? Now here we go. What pattern do you notice? Well, the first thing I should notice about a perfect square trinomial is that its C term is a perfect square. And so with that, my C term is a perfect square. My b term, the other thing I need to notice about this is my b term is the square root of c added to the square root of c. So if I take the square root of c and I add it to each other, so take the square root of in this case, 16. If I took square root of 16, which is 4, and I added 2, is 4 plus 4 equal 8. Yes. You're going to notice there's several of these patterns that we can use. X squared plus 10x plus 25 is a perfect square trinomial. X squared plus 8x plus 16 is a perfect square trinomial. X squared minus 6x plus 9 would be a perfect square trinomial. Because in all of these, all three of these, my c term is a perfect square. 25, 16, and 9 are all perfect squares. And if I take the square root of that number, which in this case would be square root of 9, which is 3, and I add the 3 together, 3 plus 3 is 6. And so those are the perfect square trinomials. With this pattern, we will always have both signs the same. And what I mean by that is, no matter what, if my middle term is going to be negative, both of them are going to be negative. So when I factor this, it's either going to be x minus inside for both, or it's going to be x plus, or x plus for both. It's going to be, both signs are always going to be the same. Now you're going to look at your b term, and that's going to determine which one it's going to be. So as I do these, whatever my b term sign is the sign that's going to be inside it. If it's a negative, there'll be negatives. If this happened to be a positive, it'd be both positive. Let's do some examples. Okay, all right, let me get this erased. All right, so here we go. X squared minus 36. I see a subtraction sign between two values. First question I might ask myself, is the first term a perfect square? Well, we've seen this already, but the square root of x squared is x. So yes, the first one is a perfect square. Look at the c term, my constant, c term, constant. 36. Is the square root of 36 a whole number? If it is, then it's a perfect square. It happens to be the square root of 36 happens to be 6, right? The square root of 36 is 6. Therefore, I know that that is a perfect square. 36 is a perfect square, x squared is. So this is a difference of squares. Always going to have one sign and the other. So the signs will always be different. Separated by whatever the square root of the c term is. And I would be done. Okay? Do another example. X squared minus 81. Is x squared minus 81 a difference of squares? Well, when I look at it, x squared we already know is a perfect square. So now we got to look at our c term. Is our c term a perfect square? We'll take the square root of 81. Square root of 81 is 9. So yes, this is a difference of squares. So this is going to be x plus 9 times x minus 9. Difference of squares. Example 5. X squared plus 12x plus 36. Perfect square trinomial is what I'm thinking that it's going to be. Here's how we're going to look. And here's how we're going to attack it. Look at the c term. Is the constant a perfect square? Square root of 36 is 6. So halfway there. We know that the square root of 36 is 6. Now, take that 6 and add it to itself. And does that add up to 12? It sure does. So therefore, I know this is a perfect square trinomial. So, same sign as my b sign, as my b term. Since it's positive, it's going to be x plus 6 times x plus 6. X plus 6 times x plus 6 can be reduced down to x plus 6 squared. I will take either one of these two answers. Does not matter. I'll take one or the other. They're both the same thing. They're saying the same thing. You will see this written on a test or a quiz like this. You better know that this means the same thing as this. All right, looking at it. X squared plus 8x plus 16. Looking at this, I want to look at my C term. Is my C term a perfect square? Well, the square root of 16 is 4. Does 4 plus 4 equal 8? Well, yeah, 4 plus 4 most definitely equals 8. Looking at the sign, it is a positive. So this is going to be x plus 4 times x plus 4, or x plus 4 squared. Perfect square trinomial. All right, a couple more. Sometimes you have to factor out a GCF first, okay? You can't always just go straight into the other forms of factoring. There are a lot of times you got to take a GCF, the greatest common factor, out first. So when it looks like it should be something but it's not, pull a GCF out first. So when I look at this, I've got 2x squared minus 32. Well, it's not a difference of perfect squares because 32 is not a perfect square. But if I factor out a 2, if I pull a 2 out, if I divide everything by 2, pulling a 2 out, 2 out of 2x squared gives me just x squared. 2 out of 32, well, gives me 16. Now, is x squared minus 16 a difference of squares? Well, I know that 16 is a perfect square, and I know that x squared is a perfect square. So therefore, I know this is a difference of perfect squares, the difference of squares. So when I look at this, I know that this is going to factor out to two binomials. X and x gave me x squared. One has to be positive, one has to be negative, because in order to get a negative C term, I have to have a positive times a negative. And this is going to be 4 and 4. So my final answer will be 2 outside of the parentheses, x plus 4 times x minus 4. Last example before we turn the page and go to factor by grouping. X squared minus 18x plus 81. Is 81 a perfect square? If I take the square root of, and you can't see that, if I take the square root of 81, well, that's 9. So I know that's a perfect square. I'm going to rewrite this over here, x squared minus 18x plus 81, so you can see it. So that's the problem we're doing. It's kind of hidden by that little white spot. I apologize for that. So I know that the square root of 81 is 9. Is 9 plus 9 18? Don't worry about the sign yet. Is 9 plus 9 18? Well, the answer is going to be yes. So now I'm going to look at my b term. Is my b term negative? Yes. A negative times a negative gives me a positive. We know that. So we can go x minus 9 times x minus 9. It's always going to be the same sign in there, and it's going to be whatever the sign of the b term is for a perfect square trinomial. This is one of these that if you know them, the factoring goes so quick. There's not a lot of work. This also breaks down to x minus 9 squared. All right, so this is special cases. Now we're going to turn the page and we're going to factor by grouping. We need factor by grouping for day 7 notes when A is greater than 1. Okay, we need factoring by grouping because of A is greater than 1. Okay, so turn the page. All right, factor by grouping. First, factor by grouping is a method of factoring an expression using a polynomial with 4 terms. That's the key That's the key to this. It's got to have 4 terms. Factor by grouping, 4 terms. Factor by grouping, 4 terms. Trying to emphasize it, okay? By grouping together terms that have a common factors, there's 3 steps. Step 1, group. First 2 terms together and last 2 last 2 terms together. So you're going to take the first 2, separate them, take the last 2 and separate them, create them, or split. Okay? Remember that word, split. Okay? Split them. First 2 terms, last 2 terms. Split them. Okay? 2, factor out GCF. That's step 2. We're going to factor out a GCF of both sets. 1 GCF for the first 2, 1 GCF of the last 2. Okay, they're going to be different. Okay, they will be different on most terms. Most of the time, they're going to be different. Sometimes they're the same. We'll talk about those. But most of the time, the first 2 will have its own set of has its own GCF. The second 2 will have its own GCF. Number 3, factor out common binomial. Okay? Factor out the common binomial. All right, I'll explain what I mean by all that here in a second. So step 1, group the first 2 terms together and the last 2 terms together. Step 2, factor out a GCF. Step 3, factor out common binomial. All right, here we go. Example number 1 of this. X squared plus 7x plus 2x plus 14. Group the first 2 terms together. X squared plus 7x, 2x plus 14. That's step 1. Step 2, factor out a GCF. When I look at x squared plus 7x, what's the greatest common factor between x squared and 7x? An x. Great. What do I have left over? If I pull an x out of x squared, I have an x left. If I pull a x out of 7x, I have a 7 left. X outside of x plus 7. That's the first step of step 2. Second part of step 2 is factor out a GCF of the second group. 2x plus 14. The only GCF between these is the number 2. If I factor out a 2 out of 2x, I get an x left. If I factor out 2 out of 14, I get a 7 left. Notice, each binomial is the same. If you do it correctly, they will always be the same. I'm going to repeat that. If you do it correctly, they will always be the same. Okay, that's the goal, is to get these to be the same. If you can factor by grouping, they will always be the same. So here we go. Step 3, factor out a common binomial. Great. Well, what's the common binomial? X plus 7. What was times those? An x and a 2. Well, this 2 is positive, so it becomes my second binomial, x plus 2. Now, I know some of you are going to ask, does the order matter? It really doesn't. It could be x plus 7 times x plus 2, or it could be x plus 2 times x plus 7. The order really doesn't matter, okay? The way we're just going to try to do it and kind of keep it simple is the x plus 7 is the common binomial, so it would go first. All right? Let's do we got 4 more examples, I think, and then we go from there. Almost there. Okay, so here we go. X squared minus 12x minus 3x plus 36. Group the first two terms together. X squared minus 12x. Group the second term, two terms together. Negative 3x plus 36. Remember, split them. Remember that. Split. You're gonna thank me for thinking that way. Split them. Put them off to the side, put them off to the side. Factor out a GCF. The GCF between x squared and minus 12x is x. What's left over? X minus 12. So what do you think we're looking for over here? You're right, we're looking for an x minus 12. Here we go. Negative 3x plus 36. Remember when I said that when the leading term is negative, we always want to factor out a negative? Here's where it comes into play. This is why it was important. I want to factor out a negative 3 here. If I factor out a negative 3 out of negative 3x becomes a positive x. Remember, I want it to match this. So I cannot take a positive and have it a negative. It won't match. Factor out a negative 3 out of negative 3x and get just an x. Factor out a negative 3 out of a positive negative, factor out a negative 3 out of a positive 36. Well, negative and positive becomes a negative. Divide this by negative 3 is what I'm doing mentally. 3 goes into 36 12 times, so it's going to be x minus 12. You notice they're going to match. If I do it correctly, they're going to match. Factor out the common binomial. X minus 12. X and negative 3 are both multiplied by that, so it becomes x minus 3 multiplied by x minus 12. Here we go, number 4. 3x squared plus x minus 12x minus 4. Group the first two together. 3x squared plus x. Group the second pair together. Split them. Factor out the GCF here, or 3x squared plus x is just an x. 3x squared, and x out of 3x squared leaves me just an 3x. And x out of x leaves me 1. X divided by x. X divided by x, same base divided by same base. 1 minus 1 is 0. X to the 0 is 1. So I have 1 left over. Factor out a negative 4 here. 4 is the GCF. Leading term is negative. Factor out a negative. Negative 4 from negative 12x gives me a positive 3x. And negative 4 and negative 4 leaves me a positive 1. Factor out the common binomial. The two terms multiplied by those common binomials come together right now. Okay, a little Beatles song there. Okay, here we go. We're about 23 minutes in. We'll do the last couple and we'll be quick. Here we go. 3x squared minus 15x minus x plus 5. Put them together. GCF the first group leaves me x minus 5. GCF the last group. Well, the only GCF between a negative x and a positive 5 is a 1. In this case, it happens to be a negative 1. Negative 1 out of negative x leaves me just a positive x. And negative 1 out of a 5, out of positive 5, leaves me a negative 5. Group the two common binomials together. X minus 5 times the two terms that are multiplied by those common binomials, 3x and negative 1, they go together. Okay, 3x squared minus 12x plus x minus 4. Group, we already done that one? We have. Don't need to do that one. We'll do the bottom two. Sorry about that. Didn't notice that they were the same. So the last two, X squared minus 12x minus 3x plus 36. Let's do this one right here. 6x squared minus 9x minus 2x plus 3. I've already done this one. I don't know why they're both on here. I think I was just trying to get this one on here. So I apologize. Poor editing on my part. It is the new school year for me too. So here we go. 6x squared minus 9x minus 2x plus 3. Group the first two together. 6x squared minus 9x. Group the last two terms together. Negative 2x plus 3. Just student coming in. So you know I'm making this during the school day. Miss Rita, say hello to the group on YouTube.
Hi.
There you go. Good luck with your games today.
Thank you.
You're welcome. So the first two group together, the last two group together. Factor out a GCF. 6x squared minus 9x. Factor out a 3x. What's common between 6 and 9 is 3. X squared and x is x. Factor out the GCF of 3x. 3 goes into 6 2 times. X goes into x squared once. Factor out a 3x from negative 9x is just a negative 3. Negative 2x plus 3. Only thing common between negative 2x and 3 is a negative 1 because the leading term is negative. Must factor out a negative 1. Leaves me a positive 2x and a negative 3. Two common binomials together. 2x minus 3. So I factor out the common binomial. The two terms multiplied by the common binomials go together. 3x minus 1. All right, that is your notes. It's 27 minutes. I'll shut it off right now. Make sure to pause, rewind, do anything you need to for it. Hopefully you enjoy your day on Tuesday. I'll see you on Thursday. Have a good day.